Get your steps in. We've got some more step going on here. This one is a cheeky step 2 question. Let's crack on. It's using a transformation of variables to solve some differential equation. We've got this lovely first order ordinary differential equation. We're going to use, they're telling us this is a substitution we're going to use, or this transformation. X is 0 and Y is 1. Let's go. Let's solve it. And then in step fashion, we are going to use the ideas from here to try and solve increasingly difficult problems, as is tradition. So, if we go y equals u, 1 plus x squared to the half, let's differentiate that. And we can use the implicit differentiation, that is du dx 1 plus x squared to the 1/2 plus u times x over 1 plus x squared to the half. Is that right? The 2 the half? Yes. Now, let's plug that in. We've got 1 over y times that. So that is du dx times 1 plus x squared to the half. Divide that by y, which is u times 1 plus x squared to the half. So that's nice. Plus that, ux, now over 1 plus x squared to the half times u 1 plus x squared to the half. That is equal to xy, which is xu 1 plus x squared to the half, plus x over 1 plus x squared. Now the really cool thing to note here is what this becomes. That is 1 over u du dx plus, now the u's cancel out here. 1 plus x squared to the half, 1 plus x squared to the half is x over 1 plus x squared. That is equal to xu 1 plus x squared to the half plus. Oh, kablamo, kablamo. Now we are left with a glorious separable differential equation. Because now I can integrate both sides with respect to x. And by being extraordinarily loose with our chain rule, this is where we end up. So that is 1 over u is equal to. Why have I got a minus there? That's just a plus, so that's minus 1 over u. Is equal to, now this does integrate quite nicely. It becomes 1 plus x squared to the 3 over 2. A 2x will pop out. We'll need to divide by 2/3, divide by 1/2, so 1/3 plus c. And then we can go from there. Right, we can go from there. When x is 0, y is 1, that means that u is 1 as well. So minus 1 is 1/3 plus c, which tells me that c is minus 4/3. That gives me the fact that u is equal to 3 over minus 4 minus 1 plus x squared to the 3 over 2. And then to get y, I times that by 1 plus x squared to the half. So y is 3 times 1 plus x squared to the half over all of that. Probably ran out of board space on the screen, but you get the gist, right? Once we get to there, we've broken the back of this question. Pretty cool. In fact, I think that's right. We'll double check in a sec. Right. Okay. Nice. how about we try the second part? Now looking at this, well, what's changed? Well, if we pay attention to all the cool things that happened, right? We discovered that when I did the implicit differentiation, the half and the squared cancel out, right? And I got 1 plus x cubed, and we wanted this term to cancel. So that is suggesting to me that we are going to make the substitution 1 plus x cubed to the power of a third. That is what that suggests to me. Right, we go through our differentiation. All right, and that's what we should get times x squared. That's what we should get. Right, let's plug that into here. Divide it by y, which is that. Divide it by y, which is that. So again, the whole point is this 1 plus x cubed to the third and that 1 plus x cubed to the third disappear. So I'm left with 1 over u du dx plus, when I divide this term by this, what happens? The u's cancel out, and that combines with that to get x squared over 1 plus x cubed, because it's minus 2/3 minus a third is minus 1. And here I think we are home and dry, because that gives me x squared times y, all right, plus this term here. And again, these go bye-bye. And the other nice thing that we're realizing is, of course, because that x squared is essentially the derivative of the x cubed, it makes that integral that much easier to work with. So what are we integrating in effect? We are integrating 1 over u squared du, and I am integrating x squared 1 plus x cubed to the third dx. So much like previously, that becomes minus 1 over u. What does this one become? This becomes 1 plus x cubed to the 4/3. I think the 1/4 balances everything I need. The 4/3 comes out, cancel, cancel, a third, 3x squared. Yeah, that works. We need the plus c. My initial conditions haven't changed. So we get minus 1 is 1/4 plus c, which tells me that c is minus 5/4, which tells me that u is 4 over 5 minus 1 plus x cubed to the 4/3. And then that tells me what y is, because we need to times it up by that. So y is 4 times 1 plus x cubed to the half. Let's color code this so that we know what we're doing. Tells me that y is 4 times 1 plus x cubed to the 1/3 over 5 minus 1 plus x cubed to the 4/3. And we can already maybe see a pattern emerging here, right? We can see a pattern emerging. Now, the original step question from the paper does say, hey, take a guess. You don't need to prove it. You've done 2 of them. Take a swing at what would be if that power there is n minus 1, and etc., etc. So we can take a swing, right? When that power was 3, right, so when n is 3, we got n is 3, 3, n plus 1, n plus 2, n plus 1. Say when n is 2, n plus 1, n plus 2, n plus 1. So we can probably make a decent guess, but let's do this properly. Right, we are going to make the substitution y equals u times 1 plus x to the n to the power of 1 over n. Let's go. dy dx is du dx times 1 plus x to the n 1 over n plus u x to the n minus 1, 1 plus x to the n. Now, 1 over n minus 1 is 1 minus n over n. Okay. Algebra. Plug it back into there. So we divide all of this by y, which again, at this point, we are seeing what happens, right? That term there gives me 1 over u du dx. Divide that by that. The u's cancel out. I'm left with x to the n minus 1 over 1 plus x to the n. Again, if you do that divided by that, you will see that that happens. Is equal to x to the n minus 1 u 1 plus x to the n to 1 over n. That's fine, we can deal with that. Plus this term here, that will go away. Kablam, kablam. So we are again left with the integral of 1 over u squared du is equal to the integral of x n minus 1, 1 plus x to the n, 1 over n dx. That gives me 1 over u. Now, 1 plus x to the n to the n plus 1 over n, which is what we've been thinking, right? N plus 1 over n plus 1 over n. And I think it's 1 over n plus 1. Yeah. Plus c. Initial conditions. Which tells me c is minus n minus 2. C is minus n plus 2 over n plus 1. And we plug all of that back in and we do our rearranging. We leave that as an exercise to the reader. But we should get y is n plus 1, y plus x to the n over 1 over n, over n plus 2 minus 1 plus x to the n over n plus 1 over n. Easy peasy, squeeze the lemon. If you like that, don't forget to like, subscribe, hit the bell so you can join us. Come hang out on the Reddit over at Lungang. Go post some questions, have a chat. Like-minded people that love a bit of cool maths. I thought this was really neat and really great way of getting into that step methodology of take an example that they give you what to do, then adapt it, then adapt it, then adapt it. It's what maths is all about, isn't it? I'm Nick. This was some maths. See you next time.